Hello everyone, welcome to the video lecture series on microprocessor and peripheral interface. In this session, we are going to cover the features, pin configuration and functional block diagram of 8254, which is programmable interval timer. So, a programmable interval timer, the IC is 8253 or 8254. In microprocessor based system, there are two important modes that are nothing but timer, which is required to provide the delay, and second one is nothing but the counter to count the incoming pulses. Presently, to implement this timer or counter in 8086 based system, there are two drawbacks. What are that two drawbacks? So that drawbacks are called as delay and counter. 8086 can provide delay of any value, but it uses or it requires the software to implement the delays. So here the main disadvantage of this delay scheme in case of 8086 is that 8086 requires to execute some instruction, and due to this 8086 will stay in busy condition while doing or while executing that instruction. So delays, this is one drawback related with the implementation of counter and timers. Next is related with the counter. So 8086 can count number of pulses arriving at the port, and to implement this again 8086 goes on checking the port. If it finds that the port is active, it increments the counter by 1, otherwise it will go on checking the port. Again here the same disadvantage is there, that 8086 will have to execute the instruction and 8086 will remain in busy condition. So in case of larger systems where 8086 wastages or the timing of 8086 is critical, waste time is critical, and that's why the specific timer ICs are required. So there are two timer ICs which are 8254 and 8253. These are the timer ICs. These are having similar functioning except few differences. So the differences between 8253 and 8254, which are nothing but the programmable interval timer ICs. So first one is 8253 and this one is 8254. So 8253 operating frequency is in between 0 to 2.6 megahertz, and for 8254 the operating frequency is 0 to 10 megahertz. 8253 uses NMOS technology while it uses HMOS technology. Here the readback command is not available, while the readback command is available in 8254. Reads and writes of the same counter cannot be interleaved, while in 8254 reads and writes of the same counter can be interleaved. So these are the differences between 8253 and 8254. Now we'll see the features of 8253 or 8254. Here I have mentioned the maximum features about 8254. So the most prominent feature of 8254 are as follows. This 8254 has 3 independent 16-bit down counters. So here in this 8254 we are having 3 down counters which are independent of each other and that are of 16 bit. These 3 counters can be programmed for either binary or BCD count. It is compatible with almost all the microprocessors. 8254 has a powerful command called readback command, which allows the user to check the count value, the programmed mode, the current mode, and the current status of the counter. So with the help of this readback command, the user is able to check how much is the count value, which programming mode is selected, what is the current mode, and the current status of counter. This information can be checked by the user with the help of this readback command, which is available in 8254, and it can handle inputs from DC to 10 megahertz. So these are some features of 8254. Now we'll see the pin configuration or pin description related with the 8254. So this 8254, as we have seen, this is 24 pin IC, pin number 1 to pin number 8. These are D0 to D7 pins, which are data pins, or we can call it as a data bus. So D0 to D7, these are data bus. These are total 8-bit bidirectional data bus lines. These are bidirectional 8-bit data lines which are connected to the system bus for data transfer between this 8254 and 8086. Means these data bus or data lines are connected between the internal, we can call it as an internal data bus of 8254 and the system data bus of 8086, and due to this the data transfer between the 8086 and 8254 is possible. After this, next it is chip select bar, that is CS bar. Here in this pinout diagram, 21 number pin is chip select signal pin. This chip select, this is, as we can observe, it is bar, that means it is active low input signal, and this signal is used for selection of 8254. If this pin is 0, means 0 signal or active low signal is received on pin number 21, then our 8254 will be active and it will take part in the data transfer from or to the 8086. Otherwise 8254 will remain in deactivated state. Next is read bar. It is also active low, pin number 22. It is active low. Again it is input signal which is used along with the address lines A0 and A1 to send the data from the counter to the data lines D0 to D7. For that purpose this read bar signal is used. Next is write bar, pin number 23. It is also an active low input signal and it is also used in coordination with the address lines A0 and A1, and it is used for loading the counters or to initialization of the counters. Next are A0 and A1, that is pin number 19 and 20. These are the address lines. These are input address lines used to distinguish the different parts of 8254, such as counters. There are 3 counters, so we can distinguish counter 0, counter 1 and counter 2, as well as the controlled word register. If the status on these 2 pins A0 and A1 it is 00, at that time counter 0 gets selected. If A0 pin is equal to 1 and A1 is 0, in that case counter 1 gets selected. If A0 is 0 and A1 is 1, in that case counter 2 is selected, and if both the pins are 1, in that case the controlled word register of 8254 will be selected. After this address lines, next pins are clock 0 to clock 2. this is clock input. Here we can observe clock 2, clock 1 and clock 0. These are clock input. So these are the clock inputs to the 3 independent counters. The pulses applied at these clock pins will be counted by the respective counter. So pulses applied to this clock 2 gets counted by counter 2, pulses to this clock 1 gets counted by counter 1, and pulses to count CLK0 gets counted by the clock counter 0. After this there is a gate 0 to 2. It is the gate control. So gate control, here we can observe gate 0 for counter 0, gate 1 for counter 1 and gate 2 for the counter 2. These gate pins are active high input signals, and these are used to allow the external hardware to control the respective counter. Means to control respective counter by the external hardware, the gate control signals, which is active high, is used. The function of gate input is independent on the operating mode. Next is out 0 to 2. This is nothing but the output. So for counter 0 we are having out 0, for counter 1 out 1, and for counter 2 it is out 2. So these are active high output lines of respective counter. The output is again independent on the operating mode. So these are the total 24 pins of 8254, which is programmable interval timer. Now we'll see the architecture, or we can call it as a functional block diagram of 8254. So the functional block diagram of 8254 looks like this. Here we can observe that this functional block diagram, it includes mainly the data bus buffer, then read write logic. After that there is a controlled word register here. Here is the internal bus of 8254, and here are the counters, counter 0, counter 1 and counter 2. So mainly the functional blocks of 8254 are 4 functional blocks: data bus buffer, read write logic, controlled word register and counter 0 to counter 2. Now we'll see in detail about this functional blocks of functional architecture of 8254. So as we have seen here, 3 counters are there, a data bus buffer is there, read write control logic is present, and a controlled register are the parts of the 8254 functional block diagram. Here each counter has 2 input signals, clock and gate, and 1 output signal out. Here you can observe for this counter 2 input signals are there, clock 0, gate 0, and 1 output signal is there, out 0. These counters, each counter is internally connected with the internal bus of 8254. This data bus buffer as well as control word register, it is also connected with this internal bus of 8254. Here it is bidirectional, it is only from internal bus to the control word. These are again bidirectional lines for connection of internal bus with the counters. The data bus buffer is internally connected with this read write logic. One output of read write logic is provided to the control word register. Similarly, this control word register signal is provided to counter 2, counter 1 and counter 0. Now first of all we'll see the data bus buffer. As we can observe in the functional block diagram, the data bus buffer, it is tri-state and bidirectional. Here we can observe the arrow is on both the sides, that means it is bidirectional, and this buffer is 8-bit buffer. So it is tri-state bidirectional 8-bit buffer, and this data bus buffer is used to interface our 8254 to the system data bus. Here it is our internal data bus of 8254, and these lines D0 to D7 of our 8254 gets connected with the D0 to D7 lines, data lines of 8086. That means for interconnection of data lines of 8254 and 8086, this data bus buffer is used. So this data bus buffer, it is internally connected to the internal data bus, as I have already explained, and this D0 to D7 pins are connected to the system data bus. The direction of this data buffer, it gets decided by the read-write control signal. As we have seen here, this signal we are getting from the read-write control block, okay, or control read-write logic. From that read-write logic we are getting the signal to this data bus buffer, and based on that the direction is decided. That means whether 8254 to 8086 or from 8086 to 8254. Here this data bus buffer has three basic functions. The programming, first function is programming the modes of 8254 or 8253. Then next, loading the count registers and reading the count values. These are the three basic functions which gets performed by this data bus buffer. After this, next important block of functional block diagram is nothing but read-write logic. Here we can observe that read-write logic. The output from this read-write logic goes to the data bus buffer, and this output goes to the control word register. So this read-write logic, it includes 5 signals, as we can observe in this diagram: read bar, write bar, then chip select bar, and A0 and A1. These are the address lines. So 5 signals: read bar, write bar, A0, A1 and CS bar. These are 8 signals which are important for this read-write logic function. In the peripheral input-output mode, the read and write signals, this read signal and write signals are connected to input read and input output read IOR and IOW, that is input output write respectively. And in case of memory mode, input output mode, this read is connected to memory read MEMR, and write bar is connected to MEMW, that is memory write. These address lines A0 and A1 of CPU are connected to here instead of A0 and A1 it should be A1 and A0. So here should be A1 and A2. So address lines A1 and A2 of CPU, that means 8086, are connected to this A0 and A1 address pins of 8253 or 8254, and this chip select signal is tied to the decoded address. The control word register and counters are selected according to the signals on lines A0 and A1. That we have seen how we can select the control word register and counters based on this A0 and A1. So if A0 and A1 both are 0, counter 0 is selected. If A0 is 1, A1 is 0, counter 1 is selected. If it is 0 and A1 is 1, counter 2 is selected. And if both the pins are 1, at that time control word register gets selected. And if both the pins are undefined, then no selection will be there. After that, the next block, important block, is control word register. This is the signal coming from read-write logic. This signal is going towards the counter. So This register is assessed when the lines A0 and A1 are at logic 1. As we have seen in previous slide, when both the signals are 1, in that case control word register gets selected. It is used to write a command word which specifies the counter to be used, its mode, and either a read or write operation. Means based on this controlled word register, the counter which we are going to use, that counter is specified. In which mode the counter will work, that mode is specified. And again the read or write operation, that is also represented by this control word register. So here one table is represented that shows the result of various control inputs. So here is that table which is showing the result for various control inputs. Here we have seen if both the pins are 0, counter 0 is there. If it is 0, it is 1, counter 1. If it is 1 and 0, counter 2, and both are 1, control word register is selected. So we have seen the function of these two pins. Now here if we know that read it is active low, write it is active low, and CS bar it is also active low. So for selection of our counters or for selection of 8254, our chip select signal should be 0. That's why here the chip select signal is represented 0. Now based on whether it is write operation or read operation, we have to make these signals active. So here first of all write is activated and read is deactivated. So from these two status we can say that counter 0 is selected and the operation selection is that write. So write counter 0 is the result for these signals on these pins. Similarly after this write counter 1 gets selected for these signals. For these signal selection write counter 2 is selected, and for this write control word is selected. Now if we make read activate and write deactivated, in that case read counter 0, read counter 1 and read counter 2 gets selected, and for rest of the cases here no any operation will be selected. Now we will see the next important part of the functional block diagram, that are nothing but the counters. So total 3 counters are present here, counter 0, counter 1 and counter 2, and each counter here consists of a single 16-bit down counter which can be operated in either binary counting purpose or BCD counting purpose. Its input and output is configured by the selection of modes stored in the control word register. Based on the control word register, the input and output of these counters are configured and the modes gets selected. The programmer can read the contents of any of the 3 counters without disturbing the actual count in the process. So these are the counters which are internally connected with the internal bus. This signal we are getting from the controlled word register, and based on that controlled word register, the mode of the counter as well as the operation of counter gets selected. Counter is having 2 inputs, clock 0 and gate 0, and one output, that is out 0. Here also clock 1, gate 1 are the inputs for counter 1, out 1 is the output for counter 1, and so on. So these are the different blocks of functional block diagram of 8254. So here in this video lecture we have covered the features, pin configuration and functional block diagram of 8254. Thank you for watching the video.